Hello, in this video we're going to have a look at simplifying. So in this first example it says 5 lots of 4 added to 3 lots of 6. So we're taking an English expression and we're going to change it into a mathematical statement. So 5 lots of 4 means 5 times 4. Added to means plus 3 lots of 6. So 3 lots of 6 would look like this. And then we can evaluate that. That's no problem at all. So we've got 20 plus 18. That equals 38. So when we come to algebra, with algebra, we have some numbers that are unknown. So we don't know these numbers. But we can still apply the same sort of concept. So this second example, it says we've got 4 lots of x. That means we've got 4 times x. So 4 lots of x plus 2 lots of x. So 2 times x. We don't know what x is, so we just have to leave that as is. Now in algebra, multiplication signs somewhat disappear. So 4 times x can be written as 4x plus 2x. And we can simplify. Okay, we can simplify 4x plus 2x will give me 6x. So that is simplifying. Let's have a look at a few more examples. We've got 8 lots of m. Okay, 8 lots of m plus 2 lots of n, so 2 times n, minus 4 lots of m, so 4 times m. So simplifying, 8 times m gives us 8m, plus 2 times n gives us 2n, minus 4 times n, m, which is 4m. Now we can simplify further because I've got some like terms here. So like terms. Like terms are terms with the same combination of letters. So same combination of letters. So I can't add the n terms with the m terms, but I can collect my m terms together. So I've got 8m minus 4m. So that minus there belongs to that term there. So minus 4m. So 8m minus 4m will give me 4m. And then I've got that 2n left over. So this is my final expression, simplified. Next example, a plus 2b plus b plus 3a. So what I want to do is collect my like terms. So I've got a plus 3a will give me 5a, and then I've got plus 2b plus b, so that will give me plus 3b. So we are simplifying. Okay, next example. 4x plus 3x will give me 7x. 7x minus 2x will give me 5x, and then 5x minus x will give me 4x. So I end up with 4x, and this is simplified. So this expression I have simplified down to 4x. Okay, collecting my like terms with the with this next example, I've got 9m, so I'm going to put a square around that. 9m minus 3m. Then circles around the n's, so plus 6n minus 4n. So in my rectangular shapes, I've got 9m minus 3m, that will give me 6m. Then I've got plus 6n minus 4n, will give me 2n. Okay, a few more examples. So 19x minus 10x. So those two I can combine together will give me 9x. Now I've got minus 3y plus y. So minus 3y plus y will give me minus 2y. Okay, next example, I've got some numbers here. So they are also terms, so I can only combine numbers with numbers. The terms that have letters in them, I can't combine them with numbers because they are unlike terms. So I've got 6x here, can combine with minus 9x, so 6x minus 9x will give me negative 3x, so 6 minus 9 is negative 3. Then I've got minus 2y, there aren't any more y terms in that expression, so I'm just going to rewrite that, minus 2y. Then I've got plus 8 minus 2. So plus 8 minus 2 gives me plus 6. So that's the final expression simplified. Okay, when we're looking at multiplying, so xy is the same as x times y. So these are like two different numbers, which can also be written as y times x. So yx or xy, they actually mean the same thing. So if I look at 2xy, that actually means 2 times x times y. Negative 13ab means negative 13 times a times b. So remember, like terms are the same combination of letters. So I've got CD here, CD and DC. All those three terms are the same, that they are like terms. So I can actually add them together. So 4 plus 2 is 6 plus 7 is 13 CD. So this expression here simplifies to 13 CD. And I write the letters in alphabetical order. Okay. Next example, I've got negative 3xy plus 8x plus 4yx minus 10 minus 2xy. So I'm going to collect my like terms together. So somewhat just ignoring the number in front of the term there. I'm looking at xy terms. So there's one there. There's another one here because yx is the same as xy. And then there's another one here. So if I just circle those and including the sign in front of them, I've got minus 3 plus 4 gives me 1. Then minus 2 gives me minus 1 or negative 1. xy. Okay, next term. There's an x term there, so and there's no other x term, so I'm going to write plus 8x here. And then I've got a number here, which I'm going to tag on to the end. Okay, so that is this expression simplified. Okay, if we just pop in some squared terms. So I've got 7x squared plus 3x. They are actually different terms. So remember, like terms must have the same combination of letters. And if we look at x compared to x squared, so if we think about x being like a length, so say x was 5 centimeters, it would look like this. Okay, so there's a line which is 5 centimeters in length. If I look at x squared and draw it, x squared would be a square. So x squared means that I'm sort of looking at the area. So if x was 5 centimeters, this would be 25 centimeters squared. So x squared is actually different from x. So I can't combine those two together. So let's have a look at one last example. So 7x squared plus 3x minus 4x squared minus 8x plus 3x squared. Okay, so my x squared terms would be here, here, including that minus sign there, and this one. So if I combine those three terms, I get 7 minus 4, which is 3, plus 3, which is 6, x squared. So I end up with 6x squared, and then I've got plus 3x minus 8x will give me minus 5x. So that's simplifying.